Good morning. Let us continue from the previous session. In the previous session, we were learning about alternating current, and we have learned some of the definitions like what is an alternating quantity, what's a waveform, what is instantaneous value, what is amplitude or peak value, what is time period, and what is frequency. And let us continue from there. Today I'll show you how you can represent an alternating quantity using mathematical expression. Here I'll take a waveform for an voltage. Let us say we have an alternate voltage waveform or voltage which varies continuously with time as shown in this graph. And the time period of this is capital T. This is E. If the peak value is EM, this is EM peak value or amplitude, and on the negative side it will be minus EM. Now how can we represent this using mathematical expression? It can be written as E is EM sine theta, or it can also be written as EM sine omega t, and you know omega is 2 pi f, so it can also be written as E is EM sine 2 pi f t, or it can also be written as EM sine 2 pi, f is 1 by t, so 2 pi by t into capital T. These are some of the standard form which we can use to represent an alternating quantity. Here we have used voltage E. You can use the similar formula for or similar expression for current, power, etc. or any other alternating quantity. Now here EM, remember EM is the peak value and frequency is F. T, capital T is the time period. Now if this expression is given, I'll show you how you can find out the peak value or the frequency or the time period of an alternating quantity. So for that we'll take a small sum and then we'll try to find out. First you take down this small question. An alternating current I is given by I equal to 141.4 sine 314 t. Find question number 1, the maximum value. Second one, frequency. Third one, time period. Fourth one, the instantaneous value when t is 3 milliseconds. The instantaneous value when t is 3 milliseconds. Okay, so here given the alternating quantity, and we can compare the given alternating quantity with the standard equation or standard representation to find out these values. So we'll try to do this solution. First write what is given. Given I as 141.4 sine 314 t. This is given. Now the standard form is standard equation for I is I equal to Im sine 314t. Now with this, what is the first question to find out? The maximum value. So compare these two equations. So question number 1, maximum value. In the standard equation, Im is the maximum value. So in the given equation, it is 141.4. Therefore, maximum value Im is 141.4 amperes. Now second one, frequency. We know in the standard form I is Im sin 314t. So this is standard form is not 314t. Standard 14 is omega t. Just correct it. The standard equation for I is Im sin omega t. So omega is 314 here. Given omega is 314. And also we know omega is 2 pi f. We know omega is 2 pi f. Therefore f is omega by 2 pi. Therefore it is 314 by 2 pi. Calculate 314 by 2 pi. It comes around 50 Hertz. And the third question is to find out time period. Time period T is given by 1 by f. It's 1 by 50. .02 seconds. Now the last question, if you go back, it is to find out the instantaneous value at t is 3 millisecond. At t is 3 millisecond as I equal to 141.4 into sine 314t, that is 314 into 3 into 10 to the power minus 3. Now how much it is coming? 114 amps. 114.35 amps. This is the value of I, or current at 3 millisecond is 114 amperes. Let us take another one. This is regarding voltage. You can just note down this. An alternating EMF is expressed as E is equal to 200 sin 314t. Find question number 1, the amplitude. Question number 2, Frequency. Question number 3. The instantaneous value when t is when t is 1 by 100, 1 by 200 second. 1 by 200 second. Okay. So now we can compare the given equation with the standard equation. Similar to previous one, only the difference is here an voltage waveform, there it was a current waveform. So just try. Given E is 200 sine 314t. Standard equation is E is equal to Em sine omega t. Comparing to, we get the amplitude. Amplitude is nothing but the maximum value. Amplitude is the peak value or the maximum value. Amplitude Em is equal to 200 volt here. Second one, frequency. Find out frequency. Omega is 314. Omega is 2 pi f, which gives f is 314 by 2 pi, which is 50 hertz as in the previous case. Last one is to find out the instantaneous value at t is 1 by 200 second. In the equation, substitute t is 1 by 200. You will get the value. Instantaneous voltage (1 by 200 second). So E is 200 sine 314 t. 314 into 1 by 200. Just calculate and let me know the value. And here this 314, actually what you have to do is, this 314 is in radians, so you may take in degrees so that you know it will be easy. Otherwise you have to use even your from the log table, now you have to take the radians value. So let us convert this into degrees itself, because 314 is in radians per second. So what I do is 200 into sine 314 is nothing but 2 pi f, right? 2 pi f. So I'll take 2 pi is 180. Pi is in radian. Equivalent degree is 180 degree into 50 hertz. 2 pi f. So 314 you take it as, I'll just write here 2 pi f. So pi is nothing but 180 into 1 by 200. So how much it is coming? Yes, 197, or approximately you can take it as 200 volts or 197.5 volts. Or actually, if you take the exact value, here what happens is, this is 200 into sine 90, it comes, sine 90 is 1, so it is 200 volts itself. It doesn't make much difference if you write it as 197.5 also, it is okay, it's right. Okay, hope you understood this problem. I'll just stop this.